Solve the system of equations. We have x plus y plus z is 4, x minus y take away z is 2, and 2x minus 3y plus z is 11. Let's call these equations 1, 2, and 3. Now, if I do equation 1 take away equation 2, that's going to eliminate the x's, and I'll get 2y's plus 2z's is equal to 2, which we could just write as y plus z equals 1. Let's call that one equation 4. If I then do equation 3, take away 2 lots of equation 2, I've got 2x take away 2x, so that goes. Negative 3y take away negative 2z, so that's just going to leave me with a negative y. And then we're going to have a z take away negative 2z, so that's going to end up being plus 3z's, and that is going to be equal to 11 take away 4, which is 7. Let's call that equation 5. Then if I do 4 add 5, the y's will disappear, and I get 4z's is equal to 8, and therefore z is equal to 2. Substituting back to 4 then gives me y is equal to negative 1, and then if we go up to the first equation here, that would give me x minus 1 plus 2 is equal to 4. So that's x plus 1 equals 4, giving me that x is equal to 3. The third equation in part A on page 8 is changed to 2x minus ky plus z is 11, where k is a real constant. The first two equations remain unchanged. Ryan decided to solve this changed system of equations and obtained correctly the statement k plus 1y is negative 4. Determine the value of the constant k so that the changed system of equations does not have a unique solution. So we have k plus 1y is equal to negative 4. If we were to take k equal to negative 1, that would give us 0y is equal to negative 4. And that can't have a unique solution. If k is any other value, then we would have some number of y's is equal to negative 4, and then y would just be negative 4 divided by that. And then we'd be able to find corresponding values of z and x. So what we want here is that k is equal to negative 1. For the value of k determined from part B, so our negative 1, state the geometric interpretation of the solution of the three simultaneous equations. So here we have the three equations, and you can see I've changed number 3 to reflect the value of k equal to negative 1. So remember, it's changed to this with k equal to negative 1, that becomes 2x plus y plus z. So the first thing to note is that none of the planes are parallel. So we haven't got any of the situations with parallel planes. So let's do equation 2 plus equation 3. So if we do that, we can see that we just get 3x is equal to 13. The y's and the z's both disappear. If we were to do equation 1 plus equation 2, we can get the y's and the z's to disappear again, and that would give us 2x is equal to 6. So this one here gives x is 13 over 3. This one here gives x is equal to 3. That's inconsistent, and that seems to me that it would lead us to the Toblerone box, where we get pairs of planes intersecting in lines.